let's begin our look at conics. Now conics is the extension to the parametrics that we looked at last year. And it all comes from the cone, so what's known as the conic sections. So depending on how you slice a cone, you can get different shapes. If you slice it horizontally like so, then you would end up with a circle as a cross section. That has an eccentricity of 0. So a circle, we say, has an eccentricity of 0. Now, if I slice at an angle, okay, but not just any angle, you'll see I've written there, it's somewhere between horizontal and parallel. So it doesn't go parallel to the edge, but somewhere between horizontal and parallel, we'll end up with an ellipse. And so the ellipse has eccentricity between 0 and 1. So if we keep turning and now slice where it is parallel, there we go, that's when the eccentricity equals 1, and we get the parabola, which is the shape we've seen already. And then we can keep twisting a little bit more. There it is. So somewhere between plus or minus the parallel. So if you imagine we're twisting, so we've gone parallel, somewhere before we go parallel again, that will get us a hyperbola. Then obviously if you imagine it rotating 360 degrees, as it now comes through parallel again, it's back to the parabola, then you keep going back to an ellipse, and then back to horizontal, you'd have a circle if you kept going around. So it's, as we're rotating that slice, the shape is changing to the different shapes. Now, if it was a vertical slice straight down, that's not just any hyperbola, that's when we get our rectangular hyperbola. And the rectangular hyperbola is like the one we're used to seeing, y equals 1 over x there. Okay, definition then of a conic, it's familiar, but it's not quite what we've seen before. If the locus of points whose distance from a fixed point, that we call the focus, is a multiple of its distance from a fixed line, directrix. Now you may remember last year when we looked at the parabola, the definition was its distance from a point was equal to its distance from a line. And that's because the eccentricity of the parabola is 1. And so that multiple is 1. So we didn't say multiple, we just said equal to. But if it's any other eccentricity, we'll get the different shapes. Alright, let's have a look at it in a bit more detail. So there's a number plane, there is random point, S for focus, and there's our directrix end there. Now for it to be an ellipse, what we're saying is the points on the ellipse will end up being closer to the focus than the directrix. Remember I said the eccentricity was less than 1. So its distance to the focus is a fraction of its distance to the fixed line. So it'll be closer to the focus than it would be the directrix. Whereas the hyperbola, there's random point, focus, directrix, that one would be closer to the directrix than it would be the focus. So points are closer to the directrix than the focus. But either way, depending what E is, there's our basic definition. PS is equal to eccentricity times Pn, or sometimes we just make eccentricity the subject, you get PS divided by Pn. And that's all I'm going to say for now. So just a really quick little introduction to conics.